My friends, Solomon Islands are islands located in Oceania, around 1,000 miles off the coast of Australia. There are actually native inhabitants who live in these islands, and in terms of their genetics, they are East Eurasians. So they are sort of closely related to people of China, Korea, Japan. Um, they are East Eurasians, but they do not look like Chinese people. They look very, very interesting. And today in this video, I am going to present to you the autosomal DNA results, predicted phenotype, traits, and the G25 results of one individual who is a native inhabitant of Solomon Islands, who is a native inhabitant of this very interesting region of Solomon Islands, which is probably the most distant place from anywhere else on Earth. I mean, it is so distant from Asia, from Europe, from Africa. It is as distant as you can get from anywhere else in the civilized world. And we are going to examine a genome from 500 years before present from Solomon Islands. Now, this genome is from 14th to 16th century Common Era. So it's a relatively recent genome, only 500 years before present, from the Oceania, from rock shelter culture in Solomon Islands. In terms of her mitochondrial lineage, it is a female, so she does not have a Y DNA, but her mitochondrial lineage is B4A1. This is the first time I'm encountering this mitochondrial lineage. I've never heard this before. It must be some kind of a unique mitochondrial lineage that is unique to people of Solomon Islands or maybe Oceania and Australia. But in terms of the G25 and the ancestry, she seems to resemble people, Nassoi ethnic group, Bajo, Acta, and Australians actually come up fourth place among the closest ethnic groups to her. So there is definitely a lot of similarity between people of Solomon Islands and native Australians. Then there is Ongi and Jarava. I'm mentioning groups that I recognize. Jarava and Ongi actually are people of Andamanese Islands, and the Andamanese Islands are located right here off the coast of South India. So there is some similarity between all of these inhabitants from South India, Southeast Asia, Oceania, and Australia. All of these people are sort of similar to each other. And what's interesting is, although they are East Eurasians, they actually, in terms of their appearance, resemble Sub-Saharan Africans. And what I'm getting to is that look at the way they look. You see, they have curly hair. These are inhabitants of Solomon Islands. They have curly, you could even say kinky hair texture. They have very dark skin tone. They have you could even confuse them for sub-Saharan Africans, but in terms of their genetics, their autosomal DNA, they are very far, very distant from sub-Saharan Africans. It is very easy to distinguish them from sub-Saharan Africans in terms of their autosomal DNA. However, in the way they look, if you just look at them, you could probably confuse them for black people, and that is because of the conditions in which they live. That is because of the tropical conditions of Solomon Islands, Australia, Papua New Guinea, and these conditions of let me get rid of the tilt. Yes, so that's because of these tropical conditions that they resemble sub-Saharan Africans, even though they are so distant from sub-Saharan Africans in terms of geography and genetics. Now let's get into the results of MAI002. And we're going to start with Nashakot calculator results. We're going to start with the phenotype results. This is going to be very, very interesting. So we're going to start with eye color likelihood distribution. And for eye color likelihood distribution, she's actually scoring darkest brown eyes at 88.4% likelihood. So she's definitely got dark brown eye color. Definitely very dark eye color. There is 0% odds for blue eyes, 0% odds for blue eyes with an amber center, 0% odds for green eyes. And even for hazel eye color, there is 0.08% odds. So she definitely doesn't have any sort of light eye color. That's a very definite prediction for dark brown eyes. For hair color, very definite prediction for black hair as well. 99.9% odds for black hair. For skin color, she's got a 70.7% prediction for dark brown skin. So she's got a very definite prediction for dark brown skin as well. Well, maybe not so definite because there's a 27% prediction for light brown skin. So for skin tone, there's sort of a split prediction between dark brown and light brown skin for her. So it's not so definite. I am very curious to see what she scores for hair texture. What's interesting is that for hair texture, she's actually scoring sort of split between straight, wavy, and curly hair. She doesn't necessarily score kinky hair, and we have seen with Solomon Islanders that although they don't necessarily all have kinky hair, they don't they also don't necessarily have straight hair. They mostly have, well, some of them have wavy hair, I guess. They don't have African hair texture. Based on the pictures I've seen, they don't have African hair texture. Also, as you can see, a lot of them have blonde hair. That's not because of you wouldn't be able to tell that with Nashakot. Their blonde hair textures is not due to the same mutations that cause blonde hair in Europeans. So you would not be able to tell blonde hair with Nashakot in Solomon Islanders. There's a different mutation that causes that in their case, and we will actually get to that a little bit later in this video, because my trait predictor also looks for that. But you would not be able to tell that with Nashakot. So you wouldn't be able to tell that this individual has this mutation from these results right here. Um, so it's interesting that she scores sort of split between straight and wavy hair and 26% odds for curly hair, and she doesn't score a substantial amount for kinky hair. For nose shape, she scores more for snub-shaped nose than Greek-shaped nose, so she most likely has a rather snub nose shape, rather short and upturned nose shape, which I guess is typical for Solomon Islanders. And for coloring related variants, it's interesting that she's got two light color variants here. So with Snipper 3, she might even score lighter eye colors, but probably you wouldn't expect that. It's interesting that she has such a dark prediction for eye color here. That's kind of surprising, despite this genotype. Okay, that makes sense. So no BEH2, no BEH3. She does have BEH1. All right, that makes sense. So she's got BEH1, but she doesn't have BEH2 or BEH3. By the way, blue eye haplotype 1, this is once again proof that it occurred, that this mutation occurred sometime much, much more distantly um, than 10,000 years ago. It occurred a long time ago, probably at the time that humans left Africa, because pretty much every Eurasian population has some people who have blue eye haplotype 1. You can find people anywhere in Eurasia with blue eye haplotype 1, even in Solomon Islands. As you can see, this individual carries homozygous light variant in blue eye haplotype 1. It is possible to find people with this genotype anywhere in Eurasia, from China to India to anywhere. Okay, no light color variants here in SLC24A5, okay, and none here in SLC45A2, okay. So no predisposition to light skin whatsoever. She does have two light color variants in this variation of Keto G, so there is some predisposition to light skin actually, but that's typical for all Eurasians once again, and no predisposition to ginger hair in MC1R. Alright, I am not going to look at Snipper 3 prediction because it's going to be brown. We can already know that because of the no BH2 and no BH3. Does it make sense to check? Does it still make sense to check? Actually, yeah, let's check. It might be green or hazel. I mean, it might still be green or hazel. I don't know. It would be funny if it was green or hazel and I didn't check. So let's check it. Yeah. Oh, it is green or hazel. Oh, it is green or hazel. Wow. That is crazy. So Snipper 3 actually predicted this sample to have green or hazel eyes. That is deranged. That is completely deranged. Well, that goes to show you that Snipper 3 has its flaws, because you cannot predict a sample who has this type of genotype in SLC24A5 and SLC45A2 to have green or hazel eyes. That is completely deranged. So this goes to show you that my tool is just this much better than Snipper 3, because Snipper 3 predicts this sample to have green or hazel eyes. So, in the hierarchy of tools for classifying samples, it's YSEC, then it's Snipper 3, then it's MAI002. That's how it ranks. Because, yeah, so this is just the dunk. This is just a dunk of Nashakot over Snipper 3. So I guess it was substantive for me to show that. Wow, good thing I showed it in this video. All right, let's look at the phenotype oracle. So it looks like the phenotype oracle for this sample looks like this. So the closest phenotypes is this, which you can compare with the, um, I guess, with the faces we see here. Actually, let's bring up the comparison. Let's bring out the comparison right now. Yeah, it looks pretty similar. Then the second closest phenotype is this. All right, which, by the way, in case you don't notice the differences between these two, the first one has wider nose shape and darker skin tone, and the third closest phenotype is this, which is a South Asian phenotype, but it's in terms of morphology quite similar to the Australoid phenotype as well. Oh, I guess, is it quite similar or is it quite different? I don't know. You tell me in the comments. I think it's a little bit similar, but it is also, I don't know. It is also different. Now for the, let's return back to Nasha code. All right, for the 5-way admixtures, let's widen that a little bit. So the 2-way admixtures, the closest mixture is a mixture of 50% this plus 50% this. So it's very straight up. The result is very straight up Oceanian looking. This individual is scoring very Oceanian, very Melanesian, very Australoid result. The second closest mixture is a mixture of 50% this plus 50% Oceanian. The third closest mixture is a mixture of percent this 50% Oceanian. The fourth closest mixture is 50% light color Oceanian plus 50% dark color Oceanian. And the fifth closest mixture is 50% dark color Oceanian plus 50%. I think this is called Vedoid phenotype in South India. So we can get from this that with the phenotype oracle, this sample is interpreted as very Oceanian looking, very Australoid looking, which I guess is pretty much spot on in terms of the phenotype of the sample. All right, now let's look at the biomarkers for this sample. And it looks like she's got a much higher than average levels of vitamin D. We can look that up actually for the levels of vitamin D. Let's go ahead and look that up. So there's 4 genotypes for levels of vitamin D, and all of them lead to higher levels of vitamin D, except for this one, which leads to a intermediate level of vitamin D. Interesting. Okay, she's got a higher level of LDL cholesterol and lower level of HDL cholesterol. That is unfortunate. Typically, you want to have the reverse of that. She's got a higher level of glucose, which is unfortunate. She's got a lower level of hemoglobin, which is really good. She's got a higher level of blood pressure, which is bad. She's got lower level of iron in the blood, so she does not have hemochromatosis. She's got lower level of sex hormone binding globulin. She's got lower level of red blood cell count in blood, and she's got lower number of base pairs for telomere length. So she's got some predisposition to lower lifespan, shorter lifespan. And for height, she's actually got a predisposition to longer than average height. Okay, I am now interested to look up what is the average height of Solomon Islanders. What is the actually let's just modify the query here. Solomon Islanders average height. 5 feet 2.7 inches. No. So they are very short. They are very short on average, but she's predicted to be taller. She's predicted to be taller than average, but they are on average very short. That is interesting. So despite them being on average quite short, she's predicted to be taller than average. That is quite a interesting thing to notice. All right. Okay, let's look at the polygenic risk scores, and we're gonna ignore everything that's close to 1. We're going to look at the things that are remarkable. So she's got a low score for kidney stones. She's got a low score for arrhythmia nodosum. She's got a high score for hemoglobin E disease. Very interesting. She's got a Actually, let's look up hemoglobin. Is this the main risk variant that I print in the rare diseases panel? Yes, this is the main risk variant that I print in the rare diseases panel. Interesting. Let's look at the other rare diseases panel risk variants. So she's got 20 times the risk of ankylosing spondylitis, carrier of one pseudosulfonase A deficiency allele, and that's pretty much it, right? So nothing else pops up. Below average odds for migraine, high odds for lupus. That has to do with the HLA gene panel, but we're gonna look at the HLA gene panel later. Um, Lower odds for gout, lower odds for thyroid cancer, really good to see. Lower odds for eczema. Lower odds for polycystic ovary syndrome, that's really good to see. So she's a female, she's got lower odds for that, that's really good to see. Higher odds for AMD, unfortunate. Slightly higher odds for Tourette's. Higher odds for epilepsy, unfortunate. Higher odds for asthma, that also has to do with HLA gene panel. So we already saw two above average risk scores for HLA gene panel related variants, two HLA gene panel related conditions. Excuse me. So we might expect something bad for the HLA gene panel. We see below average risk score for leukemia. We see average for vitiligo. We see that also has to do with the HLA gene panel, but okay. We see above average for myopia. We see above average for corneal astigmatism. Wow, that's very interesting. That's actually very high for corneal astigmatism. That's very interesting. We see high for primary biliary cirrhosis. We see below average for stroke. We see below average for male pattern hair loss. So she does not have a predisposition to male pattern hair loss. Good to see. She has below average predisposition to atrial fibrillation and below average predisposition to cardiovascular issues. Really good to see. Now she's got a below average, actually above average predisposition to ADHD, below average predisposition to unipolar depression, above average predisposition to bipolar type 1, and high predisposition to schizophrenia. So there is high predisposition to bipolar and schizophrenia, and very high predisposition to type 2 diabetes. And that was counted with 9 S&Ps. So based on these 9 S&Ps, she's got a very high predisposition to type 2 diabetes and average predisposition to type 1 diabetes. All right. Then there is a above average predisposition to Alzheimer's and average predisposition to multiple sclerosis. All right. So the score for type 2 diabetes here is very high, which is kind of concerning. She's got 1 risk variant for breast cancer out of 12, and above average also prostate cancer, and 13 risk variants out of 20 for testicular cancer. And she's actually got 2 risk variants for testicular cancer in both the risk variations and Kittel G. So she actually has the risk haplotype in Kittel G that has to do with increased risk for testicular cancer. That's very typical for Europeans and West Eurasians in general, but she is not a West Eurasian. She is an Oceanian. So it's kind of interesting that she has this type of genotype here in Kittel G. I suppose it might be a Eurasian thing, not just a European thing, but I think relative to the rest of Oceanians, she does have an increased odds for testicular cancer based on that. The good side of the coin is that she is a female and she does not have testicles, so she doesn't really have to worry about testicular cancer all that much. Also, Europeans who actually do have this genotype, most of us have the same genotype here. Most of us have the risk haplotype for testicular cancer in Kittel G. Most of us do not go on to develop this testicular cancer at any point in our lives, despite having this risk haplotype. So it's not that big of a deal anyway. She's got no risk variance for celiac disease out of 8, really good to see. No risk variance for GSS. 1 risk variance for Crohn's out of 20, but it's not marked as important, so that's not that big of a deal. No risk variance for Riefenstein's. No risk variance for Parkinson's. Gilbert syndrome, she's got 1 risk variant here, but I don't remember it being that important. We can look it up, but I'm not going to. No risk variance for basal cell carcinoma, no risk variance for anything else. 8 for allergies out of 22, which is very typical. Yeah, I don't see anything else here, anything that's uncommon. I don't see anything that's uncommon here. Pretty good. So the only things that we really have to watch out for is the score for type 2 diabetes, and type 2 diabetes is the risk here. And I think bipolar and schizophrenia as well. And that's it. All right. Now let's go through the monogenic traits and find out what else is here. So when it comes to warrior versus warrior, she's definitely much more of a warrior. That has to do with COMT, MAOA, and MAOB genotypes. She's got predisposition to being a warrior, which means higher activity of the COMT, MAOA, and MAOB enzymes, quicker dopamine reuptake, quicker activity of these enzymes that break down dopamine, so lower dopamine levels, higher stress resiliency, and less ability to motivate themselves in low stress environments. But in higher stress environments, better performance and better um, ability to perform. So higher stress resiliency. People with this type of phenotype are better suited to such jobs as, say, a firefighter or a cop or a soldier. Whereas a warrior phenotype, that's somebody with a slower dopamine reuptake, somebody with lower activity of the COMT, MAOA, and MAOB enzymes that break down dopamine, so higher dopamine levels at all times, which means higher ability to perform under low stress conditions when naturally the dopamine secretion is quite low, but you naturally have higher dopamine levels anyway, so you have higher ability to perform under low stress conditions, and like such as school, for example, or college. So these people have are better suited to such jobs as a teacher, or actually maybe not a teacher, because teacher is a stressful job, but maybe a scholar or a researcher, right? But in a stressful condition, these people don't perform very well. So this person is much more of a warrior. It's also very, very ethnically linked, by the way. Warrior is a very European phenotype to have. Warrior is more of a phenotype that's found outside of Europe. So this person has a phenotype that's very much linked to non-European ethnicities. When it comes to DRD2, this person has a genotype that's linked to higher number of dopamine D2 receptor sites in the brain, which means higher predisposition to such conditions as schizophrenia and bipolar, which we have already seen with the polygenic risk scores. So they have a higher predisposition to schizophrenia and bipolar. That's pretty obvious. This is also not a very European thing to score. Europeans have a slight predisposition to less dopamine D2 receptor sites in the brain. It's a European trait to have less DRD2 receptors, because most of these variations that have to do with DRD2, the variant that has to do with decreased number of D2 receptors is more frequently found in Europe. Except I think TAC1. TAC1 is the one exception, I think, where the variant that leads to less D2 receptors is more frequently found in Native Americans, I think. Don't quote me. I think it's I might be wrong. I think it's East Asians or Native Americans, but it's not Europeans. And TAC1 is the one exception. Every other variant, it's Europeans. For 5-HT and serotonin, this individual has predisposition to lower or intermediate levels of 5-HT and serotonin, so higher predisposition to such conditions as depression and anxiety. And for autism, she has a predisposition to intermediate or lower levels of autism, so that's really good. So some protection from autism. Did I miss anything else? I did not miss anything else. All right. For lactose persistence, she has a predisposition to intermediate or higher loads of lactose intolerance. So she is not lactose persistent. She does not carry any risk variance for lactose persistence. For empathy, she's got a predisposition to higher or average level of empathy, which is very interesting because East Asians and East Eurasians in general tend to be scoring lower level of empathy for OXTR, but she is actually scoring higher level of empathy based on these 5 SNPs. You can even see that some of these variations in OXTR, the genotype literally says most likely not East Asian, which is very interesting. And I guess she is not an East Asian, she's an Oceanian, but still, Oceanians are very closely related to East Asians. So it's very interesting that she scores this genotype that says not East Asian, right? It's very interesting that there's such a big difference when it comes to empathy genes between Oceanians and East Asians. But anyway, she is scoring higher level of empathy for OXTR panel. Now, for diabetes, she has this genotype which is to 5 times the odds for type 1 diabetes, which is very interesting. We can expect to see something very interesting for the HLA gene panel when we get to it. But there's also this genotype, which is a 7-fold decrease in risk of type 1 diabetes. But okay, we're going to take that into account. There might be something interesting in the HLA gene panel because both of these genotypes are in the HLA gene. They're both in the HLA. No risk variance for Alzheimer's and APOE, really good to see. And one risk variance for MS and HLA, which is very interesting. So there are some risk variants for various common conditions in the HLA gene. For cardiovascular issues. She's scoring lower odds of cardiovascular issues, which is really good to see. So some predisposition against cardiovascular issues. For facial morphology panel, no East Asian EDAR, which is very big. And then they got one European EDAR alleles here, and then they got likely some East Asian facial traits, most likely non-European ethnic background. So when it comes to EDAR genotype, it's kind of a hit or miss. Like some of the EDAR variants, like for example, this variation, they got fully European genotype here, fully West Eurasian, non-East Asian genotype in EDAR in this variation. This is the main EDAR variant that is used to determine East Asian ancestry in most cases. And then these are the two alternative EDAR variants that I added for my trait predictors ethnicity panel that also can be used to determine ethnicity. And here they score heterozygous in this variation and homozygous East Asian facial traits in this variation of EDAR, which is very interesting. So it looks like when it comes to EDAR genotype, in here they score no East Asian variants, here they score one East Asian variant, and here they score two East Asian variants. So that's very interesting. They have a genotype for shorter mid-face length, intermediate odds of protruding nasal bridge, intermediate nose size, nose pointing up, thicker eyebrows, and higher odds of missing teeth. Very interesting. I wanted to get to something that had to do with albinism and blonde hair in Solomon Islanders, but I didn't get to that yet. So they don't have vitiligo. Really good to see. I mean, they have a higher odds of vitiligo here, but they don't have the HLA variants of vitiligo. But we're gonna get to something in a couple of seconds, actually. Okay, so they don't have micropenis. They don't have photic sneeze reflex. We're gonna get to something real quick. Yes, albinism in a typical traits panel. This is where I put the Melanesian blonde hair variant, and this is not in the file, unfortunately. This file does not have the information on the Melanesian blonde hair variant, and that's very sad. So this file is not high quality enough to have this information in the file. The only thing we know is that this sample doesn't have a cutaneous albinism type 1b or type 2, but unfortunately, this file doesn't have the information on Melanesian blonde hair variants, and that's very sad. But if it was higher quality, and I will try to find a different, maybe Melanesian or Solomon Islander file, I will try to look for that, and maybe I will find something that is higher quality that carries the Melanesian blonde hair variant, and I will try to make that a video. But it looks like this sample doesn't carry the Melanesian blonde hair variant. Or maybe it does. Maybe it does carry it, but I don't know it. I can't know because it's not in the file, because the file is too low quality. Doesn't have this information. No risk variance for increased pain sensitivity. What else can we talk about? Too much information. None of it is any interesting to me. No variance for familiar Mediterranean fever. Good genotype here in MTHFR. This is a risk genotype, but from what we know about the cardiovascular result for the polygenic risk score, I think the result for homocysteine panel is going to be good. So this one risk genotype is not going to spoil the result too much. BRCA, overall it's looking really good. Overall it is looking really good. Although there is this one risk variant here. It's not even BRCA, it's something else. It's a different, it has nothing to do with breast cancer. It's just here, but it's not about breast cancer. For alcoholism, slightly above average risk score, very interesting. Celiac disease, no risk variance for celiac disease and HLA gene, really interesting. Canavan syndrome, no risk variance for Canavan syndrome. She does have this genotype. She has the A allele here, which protects from baldness in the AR gene, which is very, very interesting. So it is a little bit surprising because the A allele, to my understanding, was mostly found in sub-Saharan Africans, but maybe it is also found in Oceanians. I'm not sure. I think it's what I know for a fact is that it is not found in Europeans, but it might also be found in Oceanians as well. I'm not sure. Okay, she does not have any protective variants from HIV and HLA-C. And for the HLA gene panel, she is scoring mostly lower odds of autoimmune disease. So HLA gene panel is looking quite good. We can check the HLA genotypes right now. Let's do it. Let's look at the HLA genotypes. So HLA-A, she does have a genotype for lower odds of lower antibody levels, which is bad. She doesn't have HLA-B27 alleles, which is good. overall she's doing quite good, but she does have some risk variants for HLA, for type 1 diabetes, and some other things, some for multiple sclerosis, for example, um, for allergies. I'm seeing some risk variants for multiple sclerosis and allergies, but overall she's doing quite good. Overall, she has much more good genotypes in HLA than bad. For homocysteine panel, she's doing quite good as well. Her results is that she's scoring intermediate homocysteine levels, even though she does actually have one risk variant even for homocystinuria, which I think might be a miscall. It did contribute to the result, but I think it is a miscall. And for muscular dystrophy myopathy, she doesn't have any risk variants for that, no risk variants for ADL either. Color blindness panel, no risk variants for color blindness anywhere. FTO gene panel, she has higher or intermediate odds of obesity. I remember reading somewhere that Solomon Islands were were a place where there was some of the highest amount of obese people or something like that in the world. I'm not sure. Is that true? Can you comment in the comments? Is this correct information that Solomon Islands was the place with the highest amount of obese people in the world? Because I remember reading something like that in the. I remember reading that Oceania, some place in Oceania, had the highest amount of obese people in the world, something along those lines. And I'm not sure if I'm remembering things correctly, but this made me think of that right now. So she's scoring highest or intermediate odds of obesity with my tool, and she's got. Well, that's why, because she's homozygous for 5 gene variants in FTO. She's got all these fat variants for obesity in FTO. She does have some genotypes for lower BMI and lower odds of obesity and insulin sensitivity, but when it comes to FTO genotypes specifically, she's got a lot of fat related variants in FTO. In fact, the only genotype in FTO where she doesn't have homozygous fat genotype is this one, where she's got heterozygous genotype. But every other genotype in FTO, she's got a predisposition to being overweight, homozygous fat genotype. So that's quite the predisposition to being obese. For syncope, no SNPs were found. For biotraits panel, let's see, she's got one copy of the hunter-gatherer and one copy of the farmer CLTCL1 gene variant, which is very interesting. I'm pretty sure that these people were hunters and gatherers until Europeans sort of discovered them. Maybe I'm wrong. Maybe you can write in the comments if I'm wrong, but I'm probably wrong. But anyway, you can write in the comments. Maybe they had their own little agriculture or something. Probably, I don't know. I never did the research, but actually it's a 50-50. I'm gambling. Maybe they had agriculture, maybe they were hunters and gatherers. I don't know. A lot of these people that Europeans discovered had advanced society and agriculture. A lot of the cases they were just hunters and gatherers. I don't really know what the case with Solomon Islanders was. Maybe they were hunters and gatherers, but it looks like she's got one copy of the hunter-gatherer and one copy of the farmer variant in CLTCL1, which leads to intermediate ability to process carbs and sugars, and the farmer allele is C, which is very interesting. And for the blood group panel, which is the last panel we're going to look at, she actually has blood type A, which is very, very interesting. Most common blood type is blood type O, but in her case, she's got blood type A. She actually scores quite a significant amount for blood type O, 6.4%, 6.5% odds for blood type O, but the most likely blood type for her is still blood type A. And this is it. This concludes my video for this sample from Solomon Islands. Leave a like if you enjoyed the video. Leave a comment if you maybe thought something was wrong. Maybe you thought I said something that's inaccurate. Maybe you want to add something onto the video. I'm going to try to search for another Solomon Island sample and maybe find a sample that does have a genotype for blonde hair variants that are unique to Melanesians. They have a specific mutation in the TIRP1 gene that has to do with blonde hair that might Nashakot does not look for. And I'm going to try to find a my trait predictor looks for it, but Nashakot does not look for it. So I'm going to try to find a Melanesian sample that does have this mutation and present a video for you of a sample like that. But currently this is what I got for you. This is a Solomon Islander sample, and this is what I got for you today. So thanks for watching. Make sure you check out the description of the video. Description always got so much good stuff. So much information in there. You can buy stuff from the description, buy my services, buy my trade predictor, buy the raw DNA file that I analyzed, buy so much stuff from the description. Thanks for watching. Make sure you check out my description, and thanks for watching. Goodbye.